All right, so let's move on. So that was the end of our independent learning time. So let's go ahead and move on to the next lesson. So in this case, we're going to go with slope-intercept form. So you've heard me say this before in the last one, the y equals mx plus b. So we've covered the slope. That's just what we got done covering. So I have a kind of an easy way to remember this, but yesterday, right? Y is yesterday. Is equal. So yesterday I made excellent breakfast. So begin your day with breakfast. So that's kind of what you think of a line, is where it begins. And M is like a mountain, so that's your slope. So that's how you remember the formula, and that's how you remember which ones go to which. All right, so looks like we have a graph. Write the equation of the line in slope-intercept form. So slope-intercept form. Well, let's see. Look at where it begins. So B again is for begins. So it begins at -3. So if I look at the y-axis, 1, 2, 3. So down 3. And that's going to be this number here, -3. That's the last number. Then from there, we're going to have to follow our slope. So up 2 over 1, up 2 over 1. And, well, we already did an exercise on how to count the slope, right? Oh, that was loud. Okay, I'll have to address that later. I don't think I'll have time to do that now. Where were we? Oh yeah, count up the rise and the run. So up 2, then over 1, up 2 over 1. And keep in mind the direction of your slope as well. So if a line is going up, that's considered positive, and if it's going down, that's going to be a negative. And that's like probably the easiest thing that people always seem to get wrong. If they get something wrong, it's usually in the wrong direction. So they're like, I don't know, they throw on a negative when there doesn't need to be one, or they'll, make it go up when it should be a negative number. So make sure you get that right. So here I can see that this line is obviously going down as I move left to right. So when I calculate the slope, I'm gonna have to go down 4, 1, 2, 3, 4. And again, make sure you say that it's a -4, and then over 5. So I go sideways 5. So that's going to be our slope. And check to make sure that you can't reduce them, because sometimes when when you get fractions, sometimes you'll have to reduce them, especially when it gives you points like this, because there might be another point in between that you can use to count from. Anyway, down 4 over 5. And then B here, the bottom. So we start at -2, so down 2. So that's going to be -2 right there. Another slope here, so looking at number 3, going down 1 over 3, down 1 over 3. And it starts from the middle, so the B is actually going to be 0. So you have to imagine this like a number line. Up is positive numbers, down is negative numbers. And that's going to be 0. Now, when we rewrite it, we don't need to put the 0 on there, because that's the identity property, right? Remember we covered properties? Well, actually, I don't remember if we covered them this time, but I know that was one of the properties, was identity property. And that is any number plus 0 is going to stay that same number. All right, and it looks like for this one here, we're starting with the equation, and then we're going to graph it. So yesterday I made excellent breakfast. So begin with breakfast. So start down here. So -1, right? That's kind of where you imagine that the line begins, is -1. Then from there you follow the slope. So up 5 over 4. Put another dot here at the up 5 over 4 part. Okay, and then let's see, what can we do with this? Oh yeah, you can also go back the other way. See how we have a small little dot over here? Well, remember, if you have a negative divided by a negative, it's still going to be positive. So by changing both of these to a negative, so that's going to be -5, -4, you can go down 5, back 4, and you can still stay on the line. And this helps because now we have 3 lines that we can connect. Now make sure you draw a straight line all the way across, okay? That's the way these lines should be. They should go all the way from at least one edge to the other edge, okay? These lines are not, they're supposed to go on forever. They don't stop or anything like that. So you got to make sure that you point out that they do not stop. All right, so let's go ahead and go to number 5. So here we have 6, which is a positive number. So we're going to start up here at the graph at 6, y of 6. And here we have no number, so we just have x. It just says -x. So it says negative, so we know it's going to go down. All right, so we know it's going to go down. But what's the number though? Well, remember, if you don't see a number in front of a variable, the coefficient is assumed to be 1. So that's where we got this -1 from. And remember that 1 is a fraction, or you can make it into a fraction. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And that's how they got this line. So down 1 over 1, down 1. And they got a lot of them just because it's really easy to count down 1 over 1. All right, now let's go ahead and move on to number 6. This one does not have a 0. Okay, I accidentally said it there. It does not have a number, and when there is no number, we say that it's going to be 0, right? So in this case, our B, where the line begins, is 0. So mark out 0 on the y-axis, and then follow the slope. Now, sometimes I get students that will say something like up to, nothing, up to, and they'll get, you know, an undefined line. But don't forget, this isn't over 1. Up 2 over 1, up 2 over 1, up 2 over 1. There you go. So we graphed a couple of those. Now, there's another way you could graph it that we call standard form. Now, why they call it standard form is beyond me, because to me, standard is kind of like what you use the most, and y-intercept form is the one that most people use. Slope-intercept form is the one most people use. So why is slope-intercept form not considered standard form? I don't know. I guess if you weren't going with the slope, and if you were looking for like endpoints, I guess it does kind of work out that way. But I don't know. The name's a little bit tricky, even though they call it standard form. All right, so again, standard form does not give you a slope. And so sometimes you have to convert it to slope-intercept form. So if we have x plus y equals 6, well, okay, that's nice and all. And you can graph this one. That one would be a pretty easy one to graph. Sometimes they have really weird intercepts. So it's better to just sort of ignore the intercepts and just use slope-intercept form. So what we're going to do is we're going to minus x from both sides, and y will now be by itself, because that's, in a way, you're solving for y. Well, actually, that is what you're doing. You're solving for y. By solving for y, y is going to be by itself. And now we have a couple of things here, right? We have negative x on this side now, so negative x plus 6. And now it looks like y equals mx plus b, or yesterday I made excellent breakfast. So it's all there. You got everything. It's now in slope-intercept form. In some cases here, like in this case, we might have a few more steps. So 5x plus 2y equals -2. Well, let's minus 5x from both sides. Okay, minus 5x from both sides. Now we have 2y equals -5x minus 2. We still got to get that y by itself, so that means the 2 has to go. So that 2, well, how do we get rid of it? Well, remember, this is 2 times y. So to get rid of something that is multiplied, we have to do the inverse, or the opposite, which is to divide by 2. So divide everything by 2. 2 divided by 2 is 1. We get 1y, or just plain old y. Now in this case here, 5 does not divide by 2. And since y does not divide by 2, well, let's leave it as a fraction. And in fact, slopes are usually better left as fractions. And our last number here, negative 2 divided by 2 would be negative 1. So now we have our new slope-intercept formula. Over here, let's get rid of our 2x, right? Because we have this 2x over here. So minus 2x from both sides, negative 4y equals negative 2x plus 28. And just like the last one, we have this number in front of the y, so we're going to divide everything by that. So as we divide negative 4 by negative 4, well, that's going to be positive 1, so just stays y. 2 divided by 4, so 2 does not divide by 4, but we can reduce it though. Negative divided by negative is positive, so that takes care of that. Okay, so we know it's going to be positive. Let's reduce it. So 2 and 4 can both be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. That'd be x. Put the x down there. 28 divided by negative 4 is going to be negative 7. And there you go. So you're just doing the same thing, just basic algebra, moving stuff around. Now, when you do this, be careful, because a lot of times people tend to want to mix numbers up. But remember, you only combine like terms, and like terms have the same variable. Well, that's the simple one. They have the same variable and the same power. But for this one here, as long as it has the same letter, or if they're two regular numbers, that is numbers without variables that we call constants, then you can go ahead and put them together. But otherwise, all of these kind of should look like y equals mx plus b. All right, I'm going to go ahead and move on to the next part here. Looks like we're going to have to convert to slope-intercept form and then do a little bit of graphing. Now for this one here, we do have a few more pages. If I look ahead, that's going to be 3 pages. And I want to make sure I finish on time. And it looks like that last page is going to be a bit of a, it's going to have a little bit more stuff on there. And again, this is review. This is stuff that you might have learned in Algebra 1 or in geometry during the year, during the normal course of the year. And I'll give you about a minute or so to get this copied down. All right, sorry, I had to just take care of one thing really quick. All right, so it looks like we're doing some more conversion. So just converting from one to the next. All right, so we have 3x minus y, and again, that's standard form. 3x minus y equals 5, and then minus 3 from both sides. So if I minus 3, we're going to have a negative 3x on this side. And we're just going to times everything by negative 1. You can times everything by negative 1, or you could divide everything by negative 1. But I think a lot of students and people would just say, well, you just flip it. Okay, you're just flipping the whole thing. And you're just flipping all the signs is what I mean. All right, I'm gonna go ahead and I'm gonna go and take attendance again, make sure everybody's here, make sure everybody came back from the break. Which actually it looks like I'm having some people leaving. So remember, if you miss either one of them, it counts as an absence for the whole day. And because the classes are a lot longer, it's like if you miss one day, it's like missing 3 or 4 days in a regular school day, from the regular time of the year. So we're not really taking absences lightly, so please show up. Okay, that's just the easiest way to make it easy for everybody. All right, so for this one here, looks like we're gonna have to get the 6x out of here, so minus 6x from both sides. All right, not a problem. We got negative 6x there. Divide everything by 8. Now, if we do this, we get 6 over 8. 6 over 8 can be reduced to 3 over 4. And don't forget the sign too. And again, that's usually one of the biggest things that happens when I'm grading papers. They get the right number or the right fraction, but they just get the sign wrong. Somewhere along the way, that negative just sort of fell out of the back of the truck or something like that. Okay, watch those negatives. 16 divided by 8 would be 2, right? And don't forget the sign, so that's going to be negative 2. And here it looks like we're going to have to divide by 4. Now this one actually is a little bit of a tricky one. Maybe I'll do this one here, step by step. So if I have negative 4y equals negative x, well, we're going to have to divide both sides by negative 4. So what happens here? Well, obviously this cancels out. The negative and the 4 both cancel out. But what happens here is that, remember, in front of a variable, if you don't have anything, it's going to be considered 1. Now, x, if it's on the top, can sort of jump off and just be its own thing, right? Because if you have it look like this, that's not going to make sense. That doesn't look like the y equals mx plus b we're supposed to have. So we're going to leave that 1 on top of there while we move the x. And then from here, because we have 2 negatives, if you have a negative on the top and bottom of a fraction, they cancel each other out, because that's just like a negative divided by a negative. Well, negative divided by negative is positive, so that's going to change it into a positive. And for here, it looks like we're going to have to, well, do the same thing. All right, so same thing. I don't think there's anything really all that different from how we did this before. So from up here, it's the same thing. But once you have it in this format, then you're going to graph it. So start with 4, up 1 over 2, up 1 over 2, up 1 over 2. And once you feel like you have enough spots to connect the line, I would recommend using a ruler or some other kind of straight edge tool. You could probably use like a student ID or a folder corner or something. And again, when you draw your lines, make sure you go all the way from one side to the other side. All right, that is the way it's done. These lines are not, because, okay, just as an example, sometimes I'll see students that go like this. These lines do not look like that. They do not just go 4 spaces and then stop. They go on forever. And that's one of the first things that you learn in geometry, is that these lines go on forever. And since we can't see this graph forever, then it has to at least go to the ends of the graph. So anyway, let's go ahead and move on to this one here. So I have the same thing, minus 3x from both sides, divide everything by 5. Now to graph it, we're going to start at 1. So we have plus 1, so up 1 on the y-axis, and then down 3 over 5. And you can also get another one by switching the placement of the, so if I have here, like they gave us negative 3 over 5. Well, you can also switch where the negative goes. See, I just took the negative off the 3 and put it on the bottom. Since this is a fraction, it still counts as the same number. So what does that do? Well, okay, now my rise is up 3 because it's positive now, back 5, and that's where this dot comes from. So now I have 3 points that I can draw a line to go all the way through. And that way it just makes it a little bit easier to make sure that, you know, the line's not, because if it doesn't go through all 3 of them, then there's an error, because sometimes that'll happen. You know, you'll get kind of turned around or miscount one of these dots, and that's going to cause you to have the line in a weird spot. So I'm going to go ahead and move on down here. And actually, this is not a lot of writing to do, so I'm going to just cover it. I know I didn't give you a whole lot of time to write this one down, but it looks like you only have like 4 things to write and then only 3 lines to draw. All right, so what does the equations look like on a graph that is completely vertical or horizontal? So as we've covered before, the slope for these would be undefined. So vertical is written in the form of x equals a, right? Where a represents the line's x-intercept. So that's where it crosses or contacts the x-intercept. So that's kind of confusing because there's 2 lines, but this one is our y-axis. It's marked y, so that we know that that's the part that comes with the graph. And if I have a line that goes straight up and down, well, there's not going to be, we cannot write this in y equals mx plus b because there is no y-intercept. Since there is no y-intercept, we can't put it in y equals mx plus b. And there's also kind of no slope either. So that's why we generally just say x equals -1, because no matter where we go, x is always going to be -1. And we would just write that as your equation, x equals -1. The slope of this one is undefined because, again, we cannot divide by 0. And if we try to calculate the slope, we're just going to get a number over 0, which, again, cannot happen. You cannot divide by 0. All right, now for horizontal lines, well, okay, how do you remember the difference between horizontal and vertical? Well, if you've ever watched a sunset or a sunrise, that sun goes behind the horizon. And that's always a sideways piece of land where you can't really see the earth anymore and the sky starts. And a horizontal line is written in the form of y equals a. Now it kind of looks like the slope-intercept form, but actually it's missing its slope. Well, it kind of has a hidden slope, but it's actually 0. And if you remember, 0 times anything is nothing. So that's why there's nothing here for the x. So A represents the line's y-intercept. So if we have this equation of y equals 3, so let's go up 3 and now start this line. Now, another easy way to remember this is that if it is missing one of those pieces, so in this case here, it's missing the x. If an equation is missing the x, then it does not touch the x-axis. If it is missing a y, it does not touch the y-axis. And that's a pretty easy way to remember it, hopefully. And if we just graph each line, so y equals 4, okay, so y, just go to the y-axis, go to where 4 is, and just draw a line parallel to the x-axis. And it's parallel because, remember, definition of parallel means that it does not intersect. So in other words, if I go sideways forever in either direction, it's never going to have these 2 lines touch each other. They're just going to stay the same distance because that's what parallel means. All right, let's go ahead and move on to here. So I have y equals -2. I'm sorry, x equals -2, which if I go back 2, my x value is always going to be -2. All right, no matter what. And since there is no y, it's not going to touch the y-axis. That's why I have two lines that are perfectly vertical in this case. All right, so let's go ahead and go here. So y equals 0. Y equals 0. Well, sometimes people will say, well, you can't graph that. Or actually, I think that's only happened a few times, but I will get students a few times that will say, well, you can't graph it because it's 0. No, where did you get that rule from? 0 is a number, and you can always show me, if I have a number line, you can point out where 0 is. 0 does have a place. It's just right here. So that's where we're going to have our horizontal line, is that it's just going to basically match the x-axis. But I know what you're saying. You're probably going to say, hold on a minute. Didn't you say if there's no x, then it doesn't touch the x-axis? Well, in this case here, this is the x-axis. All right, so I'm going to go ahead and move on. Now, this last page is a little bit more, it's got a little bit more stuff in it. I was about to say a little bit more content heavy. Which, yeah, it does have a little bit of stuff in it. And we only have about 15 minutes left. So I'm going to kind of do what I normally do when I'm like this now. It's kind of weird because one Zoom is like 50 minutes or 55 minutes. What is that? Yeah, 50 minutes. Then the other one is 45 minutes. So like one is always going to be 5 minutes shorter. And the way these lessons are written, they're designed to fit right into that time period. So I think I'm starting to notice that a lot of times the second lesson usually gets cut a little bit shorter. So I'm going to leave this up for about 3 minutes. I'm going to move to the bottom for about 2 minutes, and then we'll go ahead and start. It should be about 10:20, and then we'll cover these as much as we can. All right, so I'm going to, actually, there's not really anything I can do right now. So I'll just wait here. Ooh. Okay, thought somebody else showed up. Okay, so it's been about 2 minutes. I'll get ready to move the slide down a bit in about another minute. So at least make sure you have probably maybe 18 through 21. All right, so it's about 3 minutes past. I'm gonna move down. Okay, good. And then we'll stay here for about another 2 minutes, and then we'll cover as many as we can before the bell. Well, there's actually not gonna be a bell, I think. But at 10:30, we're gonna have to switch classes anyway. Okay. Just one more week after this. So one more day and one more week after today. Let me check my timer. All right, you got about 40 more seconds and then we'll start. If you're still a ways away, maybe what you could do is just start with 28 and 29 and then work your way up. Because when I scroll back up, that way you'll see some of them still in view. All right, about 10 more seconds. All right, that makes it a lot easier to keep track of time. Okay, determine whether the equations are parallel, perpendicular, or neither. So those are the only, well, two options you have. So let's look at the slope. Now this one's pretty easy because they're already both in slope-intercept form. They're both in the y equals mx plus b. So I can just look at the slope here and I can see, okay, it's 5. That one's 5. 5 and 5, well, that means they're parallel, right? Because remember, parallel lines have the same slope. And if you think about it, they're kind of heading in the same direction. Perpendicular ones, that's the one you have to remember the rule on. And that was, it's going to be opposite sign and it's going to be reciprocal, which means the fraction part is going to be flipped. So here I have y equals -3 over 2x plus 4 and y equals 2 over 3x minus 7. We don't care about the 4 and the -7. Okay, that's just, we don't care about that at all. The only thing we want is the slope. So we rewrite them here. And now we can just look at the slope without all the extra stuff going on, without any of the distractions. And here it's easy to see that we have, well, -2, well, the one's negative, the other is positive. One is 3 over 2, the other is 2 over 3. So we know that they are perpendicular now. Okay, so with 20 and 21, it looks like they're not in slope-intercept form. So we're gonna have to change it into slope-intercept form. So to change it into slope-intercept form, remember, we're gonna have to do a little bit of algebra. So minus x from both sides. So minus x here, minus x there. And it doesn't show the work, but that you can tell that's what happened is that if x is minus from both sides, then we're gonna get -x here. Divide everything by 2. So everything got divided by 2. Now we have the slope-intercept form. So take the slope, in this case, it's gonna be -1/2. Do the same to this side here, -6x from both sides, divide everything by -3. And remember, when you divide by a negative, that's gonna switch the sign also. So that's why this slope was negative and now it's positive. Our regular number was positive, now it's negative. So that sign's gonna be switched. And again, switching signs is usually the biggest thing that I notice a lot of people miss. So in this case here, our slope is going to be 2. Looking at the slopes, -1/2 and 2, well, you might be saying this is neither at first, but remember, this is considered a fraction of 2 over 1, because any number can be turned into a fraction by being divided by 1. That's the identity property. And there you go. Now we know it's perpendicular because they're opposites and reciprocals. All right, it looks like with this one here, we have one that is already in slope-intercept form, but this side is not. So when we change it into slope-intercept form, we can look at their slopes. They're both 1. So since they're the same, that means they will be parallel. All right, I'm gonna move on down. So like I said, hope you had like 3 minutes to write those top ones. So now, if you haven't got these bottom ones, go ahead and start getting them now. Okay, so this side here looks like minus 3x from both sides. Now, when you solve for something, like in this case, we're solving for y, you have to get that y all the way by itself. That negative has to go as well. So if we divide everything by -1, that's going to switch the signs of everything. So see, negative, positive, negative, positive, positive, negative. So all of the signs got switched. Now we can see our slope. That would be 3. Now, if you forgot to reverse the sign, you might be looking at this and saying 3 and 1/3. Well, they're not opposite, so that would be, well, in this case, they are still not neither. Because even though they are reciprocals, they have the same sign. They are both positive. Remember, one of them has to be positive, the other has to be negative. Just like in this case here. So we did all the algebra stuff, and we have our slopes now. 2/3. Wait a minute, why does it say perpendicular when the slopes are not matched? Okay, well, let me just check the work really quick. So -3 divided that by 2, okay. Somehow it went from 3 over,
yeah.
What's that?
The typo that, well, the 5 should be a 2.
Yeah, okay, so now I see it. Yeah, I didn't write this. This is the way the book came to me. So, but now I saw it because I was looking at this and thinking, well, okay, that should be, 2. And if it is, well, it is 2 and it's supposed to be, but I can't erase it. It's part of the packet. Well, then it would be perpendicular because it's 2/3, 3/2. One is a negative, the other is a positive. So yeah, that's just a typo. It's just the way it's supposed to be. Anyway, let's go ahead and move on to here. This one is already in slope-intercept form, so we can just take the slope right out of it. We don't have to do any work. Over here, well, minus 2x from both sides so that I have -2x here. And we have an 8 on the y, so we have to divide everything by 8. So if we divide everything by 8, looking at our slope, we get -2/8. And in that case, remember, always check to see if you can reduce your fractions. Okay, reduce your fractions. 2/8 can be, and let me just go ahead and write that down right here, 2/8. And in this case, it'd be -2/8. So divide both by 2. So divide your top number by 2, divide your bottom number by 2. And that would be -2 divided by 2, that'd be 1. And it would still be negative. And this would be 4. So that's how they got this slope of 1/4 or -1/4. And then we identify the slope. And now I can see that both of these slopes are the same. And if they are the same, that means they will be parallel. Parallel lines have the same slope. All right, and for this one here, looks like we already got everything solved for this one. So let's move on over to this one here. Minus 12x from both sides. -12x divided by -4. So that would be, well, -4. So -4 here, -4 there. Well, that one was a pretty straightforward one. I don't see anything really weird about that one. But it is parallel because they have the same slope. And again, I do get students on these ones here that will say, oh, well, if one of them is undefined, then that means it's neither of them or cannot be solved or something. They say that. So undefined does not mean cannot be solved. It does not mean no answer. It does not mean anything like that. When you are talking about slopes, you are only talking about a line that goes straight up and down. When you are talking about a zero slope, you're talking about a sideways line. So when I graph both of these lines, you can see that they are perpendicular. Now it's kind of hard to tell because they don't have their slope showing. Neither of these has a slope technically, or one has a 0 slope, the other has no slope. So looking at the slopes is not going to work. So in this case here, I did graph it a little bit. And I can see now, looking at the graph that I just drew, that they are perpendicular. Over here, well, they're both x, so x is equal to 9. So if I draw my basic graph like this, and I'm gonna use red to show the lines. So x equals 9, so it's gonna be like way over here. And then x equals -5, that's gonna be like right here. Well, those lines are, you can see that they are parallel. So on some of these, you might have to graph it a little bit. And that's what I would recommend, just graphing it a little bit. And now you can see they're parallel. All right, I'm gonna go ahead and move over here. So which line is parallel to this one here shown below? All right, so we want the slope to match. So 1, 2, 3, 4. So that's an up 4. And then from there, 1, 2, 3. So up 4 over 3. And now we just got to look through all of our multiple choices and look for one that has the slope of 4 over 3, which in this case would be this one here. So you might have to work a few of them out, but you can pretty much pick the one that you need. All right, so let's see, moving on to this one here. Which one is perpendicular? So we want one that is perpendicular to down 1 over 5. So actually what we want is we want the slope to be not negative, so it'd be 5 over 1, or just plain old 5. So let's look at all of these choices. And now if you were working on this on your own, you'd probably have to try all of them and solve them, or pick ones you think might be the one that you're looking for. So in this case here, it would be A. So yeah, just solving it out, you'd see, hey, wait a minute, that one has the slope of 5. So that's what we're looking at. And if we were to graph that line right here, this one that we just got done getting, we'd have to start at -3 and then up 5 over 1, up 5 over 1. So it looks something like that. And you can see that if I, well, okay, that's a pretty good line. But if you tilt your head a little bit, yeah, it looks like it would be perpendicular. All right, but we're not actually graphing it. It doesn't say anything about graph it. It just wants you to pick the one that'll fit. Okay, actually, we did manage to get through the whole thing. I was not expecting to get through the whole thing. All right, so we already had the independent student learning. I hope you asked all the questions you were hoping to get, right? Because we don't have a whole lot of time to be waiting for packets and all, because we only have next week and that's it. So hopefully you already turned your week 1 packet in. If you have not turned your week 1 packet in, like do it really soon, okay? Like really soon, like before tomorrow maybe, or even tomorrow at the very latest, because I don't want people waiting and waiting and waiting, because once the summer school day ends, that's it. Okay, so start turning in your packets. Start working as much as you can, get them as full as you can, and turn them in, because by next week, or hopefully by the end of this week, you should also turn in your week 2 packet. And right now we're on 3, so 3 should be in next week, hopefully Monday or so. So again, don't wait. You know, if you don't get these packets in on time, they might be worth 0 points. All right, so that's it for today. I'm gonna go ahead and close this out. I have to close the entire Zoom out. So I know some of you guys are here for my second hour already popping in. So you're just gonna have to sign in again. Sorry. I'll see you in 1 minute. All right, thank you. I'll see you in 1 minute. Bye.